Okay, simple superposition lesson. We've got this circuit here where we have a 12 volt cell, these 3 resistors and a 6 volt cell. We're trying to predict the current through this central branch that I'm calling I3. The idea of superposition is we can remove all but one power supply at a time, replace the power supplies with shorts, and measure the current just due to one power supply. If we do that for each power supply in turn, we add together the current each due to the single power supply. If I cheat and find out with this ammeter what the current actually is, the ammeter will tell me we've got about 68 microamps. Here's the circuit with kiloohms. Here's the same circuit with the same voltages, but with ohms. What this means is the measured current will be in microamps, whereas the calculated current I'm using from this will be in milliamps. Just be 1,000 times smaller. Right, so the theory of superposition says I can predict that current by removing this power supply, replacing it with a short, and measuring that current I get just to the other power supply. So due to just the left-hand generator, I'm getting about 25 microamps with the right-hand generator completely removed and replaced with a short circuit. So if I keep that figure in my head, 25 microamps, remove the short, put the power supply back in. Now do the same with the other side. Replace this side with a short. I'm getting 43 microamps. So I've got about 25 plus 43. I'm getting about 67 microamps. If I just confirm that with the total, the total due to them both, 67, 68 microamps. So that's the theory of superposition. We can work out the current due to both power supplies by removing a power supply at a time, replacing that power supply with a short. Do that for each one. The total current due to both power supplies, we just add those two currents together. Okay, some calculations there. I'm going to do what I did with the power supplies as a calculation. I'm trying to predict this current for the central branch using superposition. So what I'm going to do is I'm going to cut my board in two. On the left-hand side, I'm going to work out I3 due to left-hand generator only. So I said I can take the right-hand generator and remove it and replace it with a short. So my circuit will look like this. Short on that side. 33, 100, 330 and 12. Okay, that's my circuit. The right-hand generator has been replaced with a short. I'm trying to work out that current I3. There's a total current leaving the supply. It's going to split by these two routes. Part of it's going to be the current I3. I'm going to work out the total resistance as seen by this battery here. I'll have this one in series with product over sum of those two. So that's 33 times 100 over the sum of those two, 133. The total current will equal the total voltage over this resistance. The current I3 is going to be called the total current times a fraction. There's the total current. The fraction I multiply by is the current division rule. I want at the top of the fraction the resistance of the opposite path, the 100. On the bottom of the fraction, I want the sum of the two parts, 133. That's my calculation of the current I3. If I tidy that up, I multiply the two fractions together, multiply the tops, we'll have 1200. We'll have 133 times 330. 133 times 330. Got my calculator. Let's try that calculator. There we go. 133 times 330. 133 times 330. 43890. 133 times this fraction, the two 133s will go, leaving you with 3300. So tighten up a little bit more. We've got that figure plus the 3300 equals that. The reciprocal of that times 1200. So that gives me a decimal value of 0.0255.4 amps. Very consistent with the circuit earlier that had that figure but in microamps. This is 25 milliamps, the one over there 25 microamps. Right, we now need to do the same with the other side. So continue my line on. I'll draw the circuit again with the right hand generator in. That's the 6 volts. I've got 100. I've got my 33. 330. And this side replaced with that dirty grey short. I'm trying to figure out the current I3 down here. There's going to be a total current over here, leaving this supply. It's going to split into these two branches and come back to the 6 volt supply. So this is I3 due to right hand generator. So I'll work out my total resistance as seen by this power supply. We're going to have 100 plus product over sum of these two. So we've got 33 times 330 all over the sum 363. I just work out 33 times 330 with a calculator. 33 times 330, 10890. Like that. 10890. That's my total resistance calculation. The total current, IT, flowing out of that battery will be the 6 volts divided by that figure. The current I3 that's coming this way will be that total current again times a fraction. Well, there's my fraction. Here's my total current. This fraction, at the top of the fraction will have the resistance of the other paths, the 330. At the bottom will have the sum of the two paths, 363. If I multiply those two fractions together, 6 times 330 at the top on my calculator, 6 times 330, we've got 1980. At the bottom, we'll have this figure times both of those two. 363 times 100 would be 36300. 363 times this fraction, well notice these two 363s will cancel, just leaving us with that figure there, 10890. If I just tidy up that calculation, we've got 1980 divided by bracket 36300 plus 10890, close brackets. That's coming out as decimal 0.04196. 0.04196 amps. So here we have about 42 milliamps. On the demonstration over there, we had about 42 microamps. So very consistent again. Those are my two currents from the two separate power supplies. The theory of superposition is I take those two, add them together. So I've got that figure plus 0.0254. I've got 0.067. 0.067. 0.067 amps. Over there on the demonstration, I had 0.067 milliamps. Okay, just to recap the practical then, with both power supplies in, I'm reading about 68 microamps. If I were to remove one of these power supplies and replace it with a short, that figure is about 25. If I put that one back in and do the same with the other side, that figure's about 43. 25 plus 43 comes out at about 68. Look up on the board, very similar to the figures that we calculated earlier. My figures in the practical are just 1,000 times smaller, having kiloohms rather than ohms. But hopefully that's consistent.